Alright, so I'm going to continue in my, this is going to be Sentential Logic 11, or 12, I forget which, but in the previous video I just did 6 logic problems which did not require subderivations, and I'll explain what that is in a minute. And I picked 6 problems and I did those if you want to go have a better idea. And I kind of did problems with the first 6 rules, the 6 rules which don't need subderivations. In this video, I'm going to be doing 4 problems, which include these 5 rules. The 5 rules which do require subderivations, and that's conjunction, introduction, tilde, elimination, tilde, introduction, wedge, elimination, and triple bar, introduction. So I picked 4 problems, which are, most of them are 15 to 18 line derivations. I picked four problems, and then in the next video I'll probably pick 4 problems, which are a bit longer and harder problems, and you kind of have to look at what you have and strategize to get what you want. And I want to talk about what a reductio ad absurdum is. A reductio ad absurdum is an argument that is often used in philosophy and logic, to where you try to get a contradiction to infer something, to get something. So a bit of an explanation. Let's say we assume B, and you know, if we're trying to get tilde B, let's say we have A and we have tilde A. If we have A and tilde A, we can exit out of this with tilde B, because we're basically reducing the whole thing to a contradiction. And if we can do that, then we can have anything that we want, basically. So if I can find my eraser where I put it. Don't know where I put it. Let's see here. There's my eraser. Don't know. Oh, there it is. Okay. So I guess I wanted to explain what a reductio ad absurdum is, and a tilde elimination is when we have a tilde and we're trying to get rid of it, and a tilde introduction is when we have no tilde on something and we want to slap a tilde on there. And we can't always just do that. We have to go through a process for this. Now, to learn how to do this, you have to just do it. You have to learn strategies, and you have to just kind of get into it and do problems and do problems and do tons of problems, and thus you will kind of learn all of this, and you will get ideas on what you need to do, given any one proof that is set in front of you. So I also want to explain again that the problems that I've chosen and the book that I think is best to learn this kind of stuff is it's called The Logic Book by Mary Bergmann, and I would suggest going there for any kind of for more problems, and that is the book that I was taught logic with, and that's the book that I continue to do problems out of, and that's what I've used to do this series. So the first problem, I've picked four problems, only 4 this time because they're longer and harder. So the first problem, we want tilde A, triple bar, we want tilde A, triple bar B, and we have a triple bar tilde B. And that's our assumption that we have. So this is going to require some subderivations. Now, a subderivation is when we have these. You know, we have to assume things to get what we want. In the previous video, I did problems which didn't require this, but now we have to get into these to do that. Now, whenever we have to get something that is where the dominant operator is a triple bar, we have to do a triple bar introduction, and to do that we have to assume this part and get that, and then assume this part and get that, and then we'll have the whole thing. So what we first do is assume tilde A. We have to assume tilde A, and we're assuming that for triple bar introduction. And not everybody does this, but what I like to do is, aside from this, is say D, because whenever I assume something, I like to put, I want to get this. This is what we're after in assuming tilde A. In assuming tilde A, we want to get B. Okay. So in order to get B, we don't really have B anywhere. We don't have B at all anywhere. So what we want to do is assume tilde B for tilde elimination. So we want to assume tilde B in order to take the tilde off, where we are assuming this to get B. And in this we want to derive a contradiction. This symbol in logic means contradiction. We want to get a contradiction inside of this subderivation. So remember, up here we have a triple bar tilde B, and having tilde B means that we have A by lines 1 and 3, triple bar elimination, and tilde A. Tilde A because we have tilde A up here, and that's from line 2, reiteration. And we have to reiterate things to show that we have our contradiction. We have A and we have tilde A inside of here. Thus we have gotten our contradiction. Now I like to kind of, once I get what I want inside of here, I like to go take a little arrow just to show that I've gotten that. So now that we've gotten our contradiction inside here, we can have whatever we want. So we can exit out of here with B. That's from lines 3 through 5, tilde elimination. And then we'll have to assume for B for bar reduction, we want to get tilde A. Alright. Similar process. We assume for A in order for tilde introduction to slap a tilde on there. And because of this, we have A, which means we have tilde B from lines 1 and 8, triple bar elimination, and from line 7 we have B, so that's a reiteration. Thus we have our contradiction. Oh, by the way, yeah, we have that too. And then we can exit out of this with tilde A from lines 8 through 10, tilde introduction. Thus we have our tilde A. And then we can exit out of both of these with tilde A, triple bar B. And that's from lines 2 through 6 and 7 through 11, triple bar introduction. All right, that's a basic triple bar introduction because we assumed tilde A and got B. We assumed B and got tilde A. And we had to do a couple of tilde stuff inside of there, and then we got it. So I'm gonna let that sit before I go to the next one here. All right, and erase. And we'll go to number 2 here. We want go a little higher since this is a 8. This is a complicated derivation that we're going to do here. This is 18 lines. The one we just did was 12 lines. This one is 18 lines. We want I horseshoe tilde D, and keep in mind that usually when you see this, you're gonna have to assume I. You're gonna have to assume the consequent to get the, or assume the antecedent to get the consequent. So, and here we have 2 assumptions. First one being F ampersand G wedge H ampersand tilde I. The second one being I horseshoe tilde F ampersand D. Okay. All right. These are both assumptions. So what we immediately know is we want I horseshoe tilde D, and we're going to have to, in this case, we're going to have to assume I. And we're assuming this for a horseshoe intro, and we want to get tilde D. All right. So we know that we have I, and having I means that we have tilde F ampersand D. That's from lines 2, 3, horseshoe elimination. So we don't have tilde D anywhere. We don't have it just sitting out for us right now at all, anywhere. So typically what we would do is, and keep in mind we have a wedge up here, and a wedge elimination is a complicated process. A wedge elimination, let's say we have over here, let's say we have a wedge B, and we want to eliminate that wedge. We want to assume A and get R, and assume B and get R. We want to assume one disjunct and get another thing, and assume the other disjunct and get the same thing. But we're getting something different out of this. All right. So, but first, we don't have. We kind of want to just look at what we have and strategize towards what we're looking for, or towards how we're going to get tilde D inside of here. So what I would do is assume D, and we're assuming that for tilde intro, and we want to get a contradiction. All right, now how are we going to get that? How are we going to get that? Now, that's when I would think that I would want to use this wedge and eliminate that wedge and try to get something. Try to get something in order to have a contradiction inside here. So what I would do is assume F ampersand G for wedge elimination on line 1. When I have a wedge elimination and I'm deciding what I'm doing, I like to put the line with which the wedge I'm eliminating is on, and figure out what we want to derive here. I would think that I would want to derive F ampersand D, because I think that we can do that, because we have an F that we can take off, and thus we have a D. We can put F and D together and have F ampersand D. We have tilde F ampersand D, thus we can get F ampersand D out of this wedge elimination, have a contradiction inside of here, and get tilde D. So what I want out of this is F ampersand D. Alright. What we can do is take F from line 6 ampersand elimination, and we'll have F ampersand D from lines 5 and 7 ampersand introduction ampersand D, and boom, we have it. And then we got to take the other disjunct and do the same thing if we can. And we'll always use a pencil if you're doing some on paper. Use a pencil that way, because when you're doing these things, you will often mess up. And like I said in the previous video, keep your bookkeeping in order. Keep your lines straight as much as you can. Like I said, mine isn't perfect, but do that as much as you can. And strategize before you start writing stuff. Strategize. Think about what you can do. What you can do with the 11 rules that you have. Alright, now we're going to assume H ampersand tilde I, also assuming for wedge elimination on line 1, we want F ampersand D, and let's see, we don't have F at our disposal here. We don't have F anywhere. So what I would do is we would assume for the contrary of F. We assume tilde F. For tilde elimination, we want a contradiction. And keep in mind that we kind of have that because we have I up here, and we can take tilde I off of that. So we're going to do that. Tilde I from line 9, ampersand elimination. I from line 3, reiteration. Boom, we have our contradiction. Thus we can exit out of this one with F, lines 10 through 12, tilde elimination. And we have D up here still, because if we're within a subderivation, we have whatever is inside of here. We can take it. Thus we can have F ampersand D from lines 5 and 13, ampersand introduction. So boom, we eliminated the wedge, and we got F ampersand D out of both of them. and thus we can exit out of that with f ampersand d. We're still inside of that one. F ampersand d. And how do we have f ampersand d? From lines 6 through 8, and 9 through 13, wedge elimination. Wedge eliminations are not simple. That I will say. They're not simple because that's, well, that's a lot of things we have to do to get this, There's a lot of stuff that we have to go through to get, to get one thing out of eliminating one wedge. Wedge introductions are very simple. Wedge eliminations are very complicated. So we have f ampersand d inside of here. And what we can do is go tilde f ampersand d from line 4, reiteration. So boom, we have our contradiction inside of here. So then we can exit out of this one with tilde d. And that's from lines 5 through 16. Tilde introduction. And now we have, the whole point of horseshoe introduction is we have to assume the antecedent and get the consequent, and we did that. So then we can exit out of this one with I horseshoe tilde d from lines 3 through 17, horseshoe intro. Hopefully you can all see that. Boom, we got it. Now that was not a simple proof at all. And I'm sorry if my handwriting is shitty, and I'm sorry if my bookkeeping is not good enough, because I'm sure that to some my bookkeeping is not very good. But that's on paper my bookkeeping is better, but on the board it's not as easy. So on to the third problem. I'm going to let that sit there for a little bit and erase. Okay. All right. This one is a 15-line derivation. We want H wedge I. And we have two assumptions. First one being tilde F wedge tilde G triple bar tilde H wedge I. Second one we have is F wedge I. Alright. Sometimes when you have something and you don't really have any ways to plug stuff in and like pull things out of others, what you have to do is assume the contrary. What you have to do is sometimes assume this with a tilde on it to prove that to get this, which is what we have to do here. Tilde H wedge I. Assume for tilde elimination, and we want a contradiction of some form. Now, having tilde H wedge I in this triple bar means that we also have tilde F wedge tilde G, lines 1, 3, triple bar elimination. This might not seem it's worth anything, but it will be. Trust me. And this might not seem it's worth anything right now, but it is also. Because what we're going to have to do inside of here is we're going to have to eliminate that wedge to get something, to get this. We're going to use this to get a contradiction in order to get that. Now, that's not always what we do, but we usually, when we have this, we use a contradiction of something else to get the contrary of that, but we're using the same thing to get its contrary. So what we're going to do, since we have this wedge, we're going to eliminate it. Assume F for wedge elimination on line 2, and we're going to get H wedge I. So we don't have H or I at our disposal. If we had H or I, we would be fine because of the rule of wedge introduction, but we don't have either of those, so we have to do another wedge shenanigan. We're assuming for tilde H, for purposes of tilde elimination, we want a contradiction. So we have F here, and if we have F, then we have one thing, we can slap any other disjunct that we want on it because of the stupid rule of wedge introduction. So what we can do is go F wedge tilde G from line 5 wedge intro. And then we have tilde F wedge tilde G from line 4 reiteration. Boom, we have our contradiction. Therefore, we can exit out of this with H from line 6, H tilde elimination. And since we have H, we can go H wedge I from line 9 wedge intro. Boom. All right, now we have to eliminate the other disjunct. For wedge elimination, line 2 elimination, line 2. Well, we have I, so this is pretty simple. Since we have I, we have the other disjunct. Boom, we got it. Thus, we can exit out of this wedge elimination with H wedge I, and that's from lines 2, 5 through 10, and 11 through 12 wedge elimination. And thus we have our contradiction because tilde H wedge I from reiteration on line 3, and thus we have our contradiction here, and thus we can exit out of here with H wedge I from lines 3 through 14, tilde elimination. Lots of times in stuff like this, you wouldn't, you have H wedge I and you would use something else in here to make contradictions, but you used H wedge I and tilde H wedge I to get your contradiction, even though that's the same thing you want. It's kind of an oddball problem, I would say. So One more problem. And we'll let that sit there for a sec so you can pause if you need to. And erase. Now this next one is a 17-line derivation that seems complicated at the outset, but is not at all. It's long, but it's not complicated. So what we want is A ampersand tilde B wedge B ampersand tilde A. And now again, sometimes when you have something like this, to get this you have to assume the contrary. So what we have is we have tilde A triple bar B triple bar B. That's our only assumption. So we don't really have anything to make this, so we're going to have to just do as follows. We just have to put brackets around the whole thing, put a tilde on that, and assume that for tilde elimination and derive a contradiction. That's a lot of what these problems can be made of. They can be made of just slapping tildes on to get the tilde off, or assuming something to put a tilde on it. That's a lot of what these problems can be made of. So, how are we going to get a contradiction inside of here to get this? Now, this might not seem like it's worth a lot. This tilde A triple bar B, and I'm going to erase that to make it more clear. It's tilde this might not seem like it's worth a lot, but you can strategize and make it worth a lot. That's how you would do that. What you want to do is try to make the contrary of this to get your contradiction to exit out with the contrary of that. So what we're going to try to do is make a triple bar, which is the contrary of that. We're going to assume A, for purposes of triple bar intro, and try to get B. Okay. Since we don't really have anything else here right now, we don't have anything else to get B from, we have to again assume the contrary of B and get B from assuming it like that. So what we can do, since we have A and we have tilde B, we can bring that together, and this is really simple actually what this is. Okay, so A ampersand tilde B from lines 3 and 4 ampersand intro, and notice that what we have just made, we have made this to make that, or to make the contrary of that. Since we have A ampersand tilde B, we can go like this: A ampersand tilde D wedge B ampersand tilde from line 5 tilde intro, and while at the same time we have tilde A ampersand tilde B wedge tilde A line 2 reiteration. Now we have our contradiction inside of here. Because keep in mind the wedge introduction rule is that if you have a disjunct of anything, you can have another disjunct added onto it. Okay, so we have that. Now then we can exit out of that with B from lines 4 through 7 to elimination. Now we have one side of that done. We're assuming B for triple bar intro, trying to get A. Similar, same process really. Since we don't have A sitting around for us to take inside of the, because one rule of thumb, whenever you close out of a derivation, you can't use anything in here. If you close out of a subderivation, you cannot use anything within it. That's just a rule of thumb. So, since we don't have A, we're going to do the same thing. Assume for tilde A, for tilde elimination, derive contradiction. Okay. And what we can do is we can go B ampersand tilde A from lines 9 and 10. Ampersand introduction. We have another disjunct of that top thing there. So we can do the same thing. From line 11, wedge intro. Alright. And then we reiterate the same thing. Reiterate this thing up here. Line 2 reiteration. Boom, we have our contradiction. Then we can exit out of that one with A from lines 10 through 13 to elimination. So we assumed B, or we assumed A got B, assumed B got A. Therefore, we can exit out of both of those with A to bar B, and that's from lines 3 through 8 and 9 through 14 to a bar intro. But wait, we have tilde A triple bar B up here. From line 1, reiteration. Boom. Alright. So then we can exit out of that one with A ampersand tilde B wedge B ampersand tilde A from lines 2 through 16 tilde elimination. Okay. That's simple, even though it seems complicated and looks complicated, it's very simple. We had this, which didn't come close to anything that we could work with our assumption. So we assumed the contrary of that, and got a triple bar, which was contrary to that, got a contradiction inside here, and thus took off that tilde. Pretty simple. And again, we, inside of these little triple bar introductions, we use the stupidest rule ever, as you can see there. So that's my second video. I'll probably be doing more and finding more problems to do that are kind of hard. If you have any questions, or if you have anything that you would like to ask, or a problem that you would like to see me do at all, tell me below, and I will respond to you. Because whenever you email, whenever you